Hi, I'm Dr. Jacob Hudis. If you're interested in math or physics content or tutoring, please check on my website, acephysics.org. The question I'm asking is, if you submerge a rock in a water-filled bathtub and measure its weight, would it differ from the weight of the same rock placed inside a sealed bag filled with water? Disregard the weight of the bag. Let me explain the question with some pictures. On the left, there's a bathtub, and at the bottom of the bathtub is filled with water, and at the bottom of the bathtub is a scale. Now imagine you take a rock. The rock is right here, and you take that rock, you put it inside the water, and you set it on the scale. The rock will have some weight, the scale will have some reading, and that will tell you the weight of that rock inside the water. Now imagine you take the same exact rock, and you put it inside of a bag, and you fill the bag with water, and you seal the bag. You then take this bag with water and the rock in it, and then you put that into the bathtub and you set it on the same scale. How will the two scale readings compare? Will they be the same? Will the rock alone weigh more, or will the rock alone weigh more or less than the rock in the bag filled with water? The answer will be provided at the end of the video.
It feels like it should be the same. I don't understand. I'm not sure why it would be.
Well, it might be the same, but can you explain why it would be the same?
Oh, water inside the bag versus outside the bag. It's all water. So I feel like, yeah. I don't see how the.
What if you weighed the two and there wasn't a it was just on a scale in air? If you weighed the two on a scale in air, which would weigh more?
Okay. Yeah, the water would weigh more.
Yeah, on air.
In air.
But
yeah.
now the water weigh more in air. But now let's say you put them in the bathtub, which would weigh more, or maybe they'd be the same. They might be the same.
Well, exactly. So the water exerts like the buoyant force. So this is the Archimedes principle, where you have to displace the water. You get the same force up. Since water and water have the same density. So if like you have put more water in your bag, you displace more. The volume increases, but the volume increases with water, which means buoyant force is gonna go up by the same amount. So they cancel each other? Okay.
Yeah, that's right. Yes.
They gave me a little clue there, but yeah.
No, that's right.
Good.
I think they're going to be the same, but I'm
Why are
not
they gonna
sure.
be the same?
Because the volume of the water in the bag increases the buoyant force on the rock and the bag by the same degree that it increases the weight
You really
of
got
the...
this. You're good at physics.
Thank you.
My only thought is that there's a small difference between the density of like the weight of the bag versus the weight of the water. We can ignore.
Okay. Let's ignore
Okay. If we can ignore that, then I would think that they would have the same weight on the scale.
Why is that?
Because the volume within the bag is filled with water, so it's not gonna weigh any different than a hypothetical same volume bag of water in the other experiment.
That's fair. It's fair enough.
Okay.
That's
Okay.
the answer. And
Okay.
they do weigh the same.
Okay.
So that is correct, and your reasoning is pretty reasonable too.
Okay.
Ignoring the weight of the bag, they probably weigh the same. The weight of the bag would be slight, but like the buoyant force of the water would be the same as the water around it. Yes. The volume displaced.
All right. The answer is that both scales will read the same value. On the left is the rock when it's submerged in the water, and let's look at the free body diagram on that rock. There's the force of gravity pulling down on the rock, and then there's also a normal force pushing up. There's also a small buoyant force, which I'm disregarding because I'm assuming that the rock is much more dense than water. Now, if we look at the same free body diagram on the rock inside the bag filled with water, the rock still has the force of gravity pulling down on it. There's still going to be a normal force pushing up on the rock because the rock is sitting on top of the scale. That normal force is the reading of weight of the scale. Then there's also the force of gravity, which is pulling on the water inside the bag. And there's also a buoyant force, which is pushing upward on the water inside the bag. And Archimedes' principle states that the buoyant force on an object is equal to the weight of the fluid displaced by the object. And so because the water displaces water, it doesn't displace a different type of fluid. The buoyant force of the water is exactly equal to the mass of to the weight of the water, and therefore the rock inside the bag filled with water will the scale will say that it weighs exactly the same as when the rock is just placed on the scale without a bag. The scale will have the same reading both times.